Okay, let us see an example still on jointed rods. So two uniform rods PQ and QR of equal length are smoothly jointed at Q. So they are jointed at Q. P is free hinged to a rough horizontal surface, and R stands on the same surface with the coefficient of friction mean. So we start with that. Okay, let us complete. PQ and QR have weights 50 newtons and 25 newtons respectively, and angle PQ to PR is 45. Find the reactions at P and R, then horizontal and vertical components of reaction at Q. This is of reaction at Q. Horizontal components of reaction at Q. So that's the question there. So what we are going to do is set by, now they are telling us they are jointed at Q. So this is our Q. We consider before separation, then after separation, when we come to the reaction and the jointed point there. So this is now going to be P, then this is going to be R. Okay. That means that it is having they are of equal length. So we say here in our solution still, let us say let 2R be the length of each rod. So meaning here I'm going to be having 2R because they are uniform, their weights are recording in the middle. So this one, remember they're telling us that PQ is 50, the weight is 50 newtons. Now this is weight, you don't multiply by D. Then QR is 25. Of course, its uniform is also acting in the middle. So this is weight, you just say 25 newtons with ease. Okay, after putting that now, because they are uniform, it means that they are going to get this in, they are going to divide this into two. So LL. So this one will also be going to be LL. Okay, because they are resting on the surface, we expect contact, and the contact results into a reaction. So reaction at P here, then here we're also going to be having reaction at R. Let me say right like that, reaction R, full stop. Now, the surfaces are rough. And they are telling us that the coefficient of friction is mu. So meaning here I'm going to be having mu R P, and also this one is going to be mu R R, because when it's about to dip, this one is going to be in that direction. Okay, they are giving us QPR as 45 degrees, and because these are equal length, it means that this is an isosceles triangle. This one is also going to be 45 degrees with ease. So we are building the question. So I think that's basically what we have. So from here up to here is to end and add this plus this. Okay. So then find the reaction at Q. So there we say to get reaction at Q. First resolve upwards. So that this one is going to be now R P plus R equaling 2. When we add these two, okay, 50 plus 25 of newtons. Means that now my RP plus R is going to give me 70. Is it 70? Yeah, 75 newtons. I call this equation 1. So now, you see now this equation has the reaction at P and the reaction at R. Means that now you say to get these reactions, you either take moments here or here. You take moments here, you get this. When you take moments here, you get that. So we take moments at N. So let us take moments at P. Take moments at P, so we shall get this one. So we start with anti-clockwise. So anti-clockwise. Now, there we need the distances from here to here, because this is when you take moments at P, this won't survive, this won't survive, and this. So forces remaining are this, and this. So we start by dividing this into two equal parts. Okay? So if this is L And I have this angle, this is going to be L cos 45 because this is an adjacent. And always from here up to here is equal from here up to here. So this is also going to be L cos 45. Okay, if I also based on this, this is up, this is the hypotenuse, this is the adjacent. So if I have this and this is the adjacent goes with the cos. So cos 45, and from here up here is the same as from here up to here. So L cos 45. Basically, you have now all the distances you want. So now you see, if you take moments at P, anti-clockwise, you see the only force anti-clockwise is this one. I think you see it's anti-clockwise. So you shall get R times the perpendicular distance from here up to here. You see, I add this plus this plus this plus this. Then that is going to give me 4L cos 45 equaling 2. Now those are the only forces active anti-clockwise. So now this one is active clockwise, even this one is active clockwise. We say these ones where I get moments from, those which are coming and those which are from this point where I get moments from, their moments are 0. And now we are using the principal moment that sum of anti-clockwise moments is equal to the sum of clockwise moments. So here, anti-clockwise we have only one force, this. And clockwise now we have these 2. So I start with this one, it's going to be 50 times the perpendicular distance from here up to here, which is going to be L cos 45. Because moments are given by the force times the perpendicular distance from a point where you're taking moments. So the other one is 25. Now times the perpendicular distance from P up to this force, 25. So I add this plus this, which will be 3L cos 45. And so that L cos 45 is common, we divide it through and this. So this one is going to be R, we are going to be having now 4R equaling to this plus 70 plus that 7, this is going to be 75 plus this we get 125. And then we divide it through by 4, we shall get our R. So I'm getting 31.25, and these are going to be newtons. So you have the reaction at R. So from what? From now 1, you see that my RP is going to be 75 minus R, which is going to be 75 minus that 1.25. And so from here, my RP is going to be, so I'm getting 43.75 newtons. So I have reaction. So this force separation, the only thing we can get are the reactions. But that's it. Then after that, now we consider the force separation so that we can get the reaction at this oriented point here. To get this and this reactions here, we separate the diagonal. Now, here I want you to take note. You look at this force. This is 50, yet this is the RP is the 43. Now means that this one and this one is, if this is 43 and this one is 50, it means for them to be in equilibrium, then the component we are going to consider the vertical component here. It can't be down, because if it's down, it's going to be greater than, it can't be balancing, it can't balance with this. So meaning, if you start RP is less than the weight which is acting downwards, if I consider this, or let me first now consider, you can either consider this or consider this. Let me consider this one here, so that people can able see. So after separation, here now common sense comes in. Okay, so let me consider this. I'm having now this there, as you see. Okay, now here what I'm telling you, this is going to be our point P. So this is going to be our P. we are going to be having reaction at P. Of course, we have our weights, which is acting downwards, which is 50 newtons. So this is our 45 degrees. Then we have this as mu RP. Mu RP. Let me add here. Oh, we can also add N. We can leave. And the mu, let me add, and the mu, so that you can get our mu also there. So this is what I have. So if I'm to extend it to this side, up now, here is what I want, it's what I'm telling you. Now, you see this one, RP, is smaller than this vertical force acting downwards. It means that now, this reaction, the vertical reaction, this is, remember, this is our point now, Q. Now at Q, this force can't act downwards because this is less than this. It means that we need a force that is going to act upwards. So this is going to be our reaction at Y, the vertical, so that when I add this and this, it's equal to this. But I can't put this one downwards because if I put it downwards, already RP is smaller than 50. Hope you are getting what I mean. Then this one is going to be my reaction at X, so meaning this time our reaction is acting in that order. So that's the point I wanted to make today. So that point, it shows that whenever you get RP, when it's smaller than this force, always this vertical component of the reaction at the joint is going to be acting upwards. That point is home now. I can handle the rest. So we said after doing that, what happens? We resolve horizontally. Resolving horizontally, we start horizontally. I have mu RP equaling to Rx. So my Rx is equaling to my RP. My RP, which is 43.75, then mu. I call this equation 1. Then I resolve vertically upwards. Vertically upwards, now I have Ry plus Rp equaling 50. But I can't say Rp is going to, okay, I can't say 50 plus Ry is going to be equal to that because it can't be possible. Because this is already 50 and this is below 50. So it means that this one we have to add a component so that it can balance with this 50. So from there I can get my Ry as 50 minus Rp, which will be 50 minus, now my Rp for 3.75. So from here my vertical component is it 6.5? 6.25 newtons. So this is the result component here. I think we start to add this plus this, we shall get 50. Anyway. Now, the other thing is to get now the other Rx, means that now we have to take moments at P. But see, we have to get Rx and take moments now anti-clockwise. It's because it's also acting anti-clockwise. As you can see, from P, this is our Rx is going to act anti-clockwise. So I'll get now this Rx times the perpendicular distance from this. So from here up to here, it's the same as from here up to here. So remember, if this is 2L, this one is going to be 2L, then sine 45, because these are adjacent. So if this is adjacent, then this becomes L. But now this one, if you consider only L, but now I'm considering the big from here up to here, which is 2L. That's why this one is 2L. If I consider only from here up to here, it will be L sine 45. But from here up to here, it will be for this side up to here. That's why I have L plus L, which is 2L. Then sine, because this is opposite. So times 2L now sine 45, because from here it's going to be 2L sine 45 degrees. That's going to be the height if we have this as 2L. Basic. It's good, that's the only. Now we also have another anti-clockwise. I think we see Y is also acting anti-clockwise. I think we see from here. It's also acting anti-clockwise. So plus now RY, then times the perpendicular distance. Now, the perpendicular distance for RY is going to be from here up to here. Remember this was, if we have that, then this is going to be L. Okay, the whole of this is going to be L. This is L cos 45 and L cos 45 from here. And I put them inside. So you see that this will add this and this is 2L cos 45. Or you could see if this is adjacent the whole of this is 2M, then cos of 45. Equaling to the only clockwise force at P, I think we see it's this one acting clockwise, I think you can see. So we have 50 times from here up here, it's L cos 45. But you can see that sine 45 is the same as cos 45, so you can divide it through. Or if you don't want that, let me bring what you can able see. Times 2L times 1 over root 2 plus RY. Our RY is known as 6.25 times 2 times 2L times 1 over root 2 equaling 50 times L times 1 over root 2. So that root 2 is common, divide through by root 2 by root 2. L, is it common? Yes, L goes. So what is remaining is 2Rx plus, this is going to be 12.5. 12.5 equaling to, we made with 150. So my Rx from here is going to be getting 18.75 newtons with this. So now we have the vertical and horizontal components and the hinge. So this is the vertical, this is the vertical, this is the horizontal at Q. So basically that's what we had to get there. Then find mu. If they want us to get a reaction at the hinge, then we will get the square root of square of this plus the square of that. That's if that was the question. I just wanted to find the horizontal and the vertical components of reaction at Q. This is the horizontal, this is the vertical basic. Okay, now get mu and mu. To get mu, I use this from one up there. This is my 43.75 mu is equaling to Rx. So my 43.75 mu is going to be equaling to 18.75. So my mu from there is going to be 3 over 7. That's the answer. So you see, with ease. So these ones are very easy, but now then my point was at this here. When you start, you have to change the direction. It's whenever this one is less than this, but whenever this one is greater than this, then you need to add this plus that RY. If this is greater than this, if this is less than this, then that's it. I wish you well. Okay, I've put this note here. You can look at it, which explains that there. So, see you.